Engineering students, if you need a refresher on parametric modeling, or if you were gone from class the day that we went through this together, I encourage you to pull up your sheet with all of the cam dimensions with this D parameter, also known as the nominal diameter. So parametric modeling, we do that so that we can change sizes on things really, really quickly. So most every dimension is going to be created with an equation or a formula instead. So in OnShape, go ahead and in your Unit 4 folder, create a new document. And we're going to call this 4.1.2 Parametric Cams. And we're going to put every cam in here that we're building parametrically. So this first part studio, I'm going to go ahead and rename it Pear Cam. And I know it's parametric because, well, that's the file that I've decided to be in. So in order to create functions or equations, go ahead and click on this variable table off to the right, and it pops open. We're not going to worry about adding drive features and things, but in this particular side of the screen, we've got a name, a variable type, value, and description. So the Pear Cam, that's the one that I want to work on, shown here. We've built this once already, but this time we want to do it parametrically. So the first variable I'm going to give, I'm just going to call it D. And the variable type is length. The description, I'm going to call this the nominal diameter. So it's just a name-only size, and so I'm going to call this a 1-inch nominal diameter. So everything that we're going to do from here on out is based on this D variable. So if I look back here, I also have some radii values. I also have this height value. So I'm going to call my next name height, let's say. So it's another length. The description is it's the distance between the two centers on this Pear Cam. And then the value, right, this is where we're going to use this expression, D divided by 2. So in this value, I'm going to have to start with the hashtag or the number symbol to pull up that D and divide by 2. And so it will switch and show me that, hey, it's actually 0.5 inches, but it is being calculated by the D parameter, because if I change the D parameter to be 5, let's say, it automatically updates, okay? So that's the cool part about using a function, is that once you change that original D parameter, everything else will change. So let's get a few other things in here. So anytime it says radius, the OnShape works a little weirdly, right? If you create a circle, you have to give it a diameter dimension. But if you make a circle and trim stuff off so that all you have left is a portion of the circle, then when you go to dimension it, then it will actually be a radius. So be very careful about when you dimension. So if I'm going to call this top radius, so make sure there are no spaces, top radius, that's another length, I'm going to go ahead and make this the D divided by 8, like it said. So hashtag D, and you can click on it to divided by 8, right? And this is the radius of top circle, right? The top part of the Pear Cam. Then there's the bottom radius, right? This bigger circle at the bottom. So again, it's a radius, D divided by 2. So we'll have to be very careful about when we dimension it. So D divided by 2, and it's the radius of bottom circle. And are there any others? Nope, because there's the through hole, right? And so the through hole doesn't change based on the size, right? Because the hole is for it to fit on the axle. And so if we're making it a circle, the axle size is going to stay just 0.25. If you want to add a function or a formula for that, you certainly can. Axle hole, it is a length, right? It's not an angle or anything like that, but specifically it's going to be 0.25, right? A 1/4 inch axle, and so it's not based on D at all. It's just a fixed number, fixed size of axle. Okay, so that can be kind of helpful, right, to include a description and things like that. So we can go ahead and roll that up. And on the front plane, let's go ahead and make a sketch. And we're going to start with a bottom circle at the origin and then another circle directly above it. Other things that we need on this pear, we need some lines, right, from top to bottom. And there we go. We also want to make sure that they are tangent. So I'm going to go over to my constraints and make sure that this line gets made tangent to the bottom circle, tangent to the top circle, and the same for the other line, tangent to both bottom and top. So it got nice and set up, and now I'm going to trim some things off. I'm going to trim this piece and trim that piece. And so it's a really tall pear because I need to actually dimension things at this point. So you can either open your screen back up and you can shift things over as needed, or you can look on the left side, your browser bar, right? These are all the functions, formulas that you have access to here in Sketch 1. So if I dimension between the two centers, right, the dimension that I want here is the height, right? So can I actually click? No, I can't click. But what I can do is I can type in there the hashtag and then choose, right? Choose the height, or start typing height. Okay, so it's in there. All right, way off to the side. Things got a little out of hand there. All right, and then top radius, right? So there's capital R for radius. Top radius. There we go. Dimension the bottom. There's the capital R for radius. So hashtag bottom radius. Yep, press enter. Ooh, so it got nice and portly, which is how this pear cam really does look, actually. And then let's go ahead and actually, while we're in here, we might as well make the circle, right? The axle radius. So you can dimension it specifically, or you can hashtag axle hole this thing. And again, it's going to be the same size no matter what. So I'm going to go ahead and green check this. I'm going to extrude 0.25. We didn't set a formula or function for that. So that's how this looks when the nominal diameter is just 1. Okay, so let's see how this changes. If I double click on and change my nominal diameter to be 5, look how different this looks, right? Because my axle hole stayed the same size. Everything else has adjusted based on that nominal diameter, this, quote, size of the first original variable. So that's a really cool way to make things change really fast. And so if you make adjustments to your project, it's a really nice way of modeling, because then everything adjusts. But only what you want, right? Anything that's a fixed size, like the axle hole, doesn't change. So that's parametric modeling. Hopefully that helps you out and gets you started and gets you going with the other 5 cams. Good luck out there.